Hello, ladies and gentlemen. Welcome to www.univrm.com. Today's video cast and podcast is on science current events with the title Temporal Cloaking. In a letter to the Nature International Weekly Journal of Science, Moti Friedman, Alessandro Farsi, Yoshimoto Okawachi, and Alexander Gaeta published an abstract of their demonstration of temporal cloaking. The team from Cornell University, working with DARPA, reported a fascinating demonstration awaiting peer replication for confirmation. This is quite different from the demonstration of the Harry Potter's invisibility cloak mirage effect shown at the University of Texas in October of 2011. The following is a quote from the article in Nature. Recent research has uncovered a remarkable ability to manipulate and control electromagnetic fields to produce effects such as perfect imaging and spatial cloaking. To achieve spatial cloaking, the index of refraction is manipulated to flow light from a probe around an object in such a way that a hole in space is created and the object remains hidden. By passing the light through the lenses and even through a medium that dispersed it, the team was able to create a gap in the light, essentially a time when no wavelength was visible. The entire experiment occurred inside a fiber optics cable and lasted approximately 50 picoseconds. Temporal cloaking, like spatial cloaking, follows all the laws of physics. Cloaking things, either in space or in time, requires the manipulation of light. Light carries information, it bounces off objects, defining their shape and sending those details to detectors such as our eyes. If an object can prevent light from doing that, it will become invisible. The system, which is the first physical demonstration of a phenomenon originally described theoretically a year ago by Martin McCall and his colleagues at the Imperial College in London in the Journal of Optics, relies on the ability to use short, intense pulses of light to alter the speed of light as it travels through optic materials, in this case, an optical fiber. In the Nature abstract, the team states, in conjunction with the theory developed at the Imperial College in London, alternatively, it may be desirable to cloak the occurrence of an event over a finite time period. And the idea of temporal cloaking has been proposed in which the dispersion of the material is manipulated in time, producing a time hole in the probe beam to hide the occurrence of the event from the observer. This approach is based on accelerating the front part of a probe light beam and slowing down its rear part to create a well-controlled temporal gap inside which an event occurs, such that the probe beam is not modified in any way by the event. The probe beam is then restored to its original form by the reverse manipulation of the dispersion. The abstract goes on to state, in their experimental demonstration of temporal cloaking in an optical fiber-based system, by applying concepts from the space-time duality between diffraction and dispersive broadening, we characterize the performance of our temporal cloak by detecting the spectral modification of a probe beam due to an optical interaction and show that the amplitude of the event at the picosecond timescale is reduced by more than an order of magnitude when the cloak is turned on. These results are a significant step toward the development of full spatio-temporal cloaking. Applying this to Harry Potter's invisibility cloak would theoretically make him both invisible and everything inside the field as if it never happened from an outside observer's perspective. Some have questioned whether this is also a demonstration of Hilbert space. This has been a videocast and podcast brought to you by www.univrm.com, and we look forward to bringing you more articles in the future.